So today we are going to discuss algebraic expression and identities. In that first part is variables. The letters used to represent numbers. Now we use small letters, not capital letter. Example X, Y, Z and A, B, C. Small letters. So the second part is constants. Constants are numbers themselves are constant. That is 4, 9 and 3. The numbers without any variable. Algebraic expression. Algebraic expressions are formed by combining variables and constants using the operations of plus, minus, multiplication and divide. The example is 3x. Here only one term is there. 5x plus 4y. Here in between plus sign is there, plus operation is there. 5x square minus 4x minus 1. Here minus operation is used. And x plus 3 plus x square. Here plus operations are used. Then the next is terms. A term is a variable, a constant or the product of variables and the constant. It can be only variable, only constant or product, like 3x square. Here 3 is a number, then x, two variables are used. 4xy, here 4 is a number, variables 5y square, 3 by 2 a square, b. These all are terms. If the term is in fraction form, then the denominator of term in algebraic expressions can be constant as well as variables. For example, x upon 2. Here 2 is there in the denominator. That is number. The next number is 3x square upon 4. Here variable is in numerator, number is in denominator. Same way, few more examples. Next part is coefficient. Coefficient is the numerical factor of a term, that is called as coefficient. Like 2x square cube plus 4x square plus x. Here in front of x cube 2 is there, so 2 is coefficient. In front of x square 4 is there, so 4 is coefficient. And in front of x nothing is there, so 1 is the coefficient. It's not 0, it's 1. So let's study one example. So here I am going to write one numerical expression, that is 10x cube minus 4x square plus 6. Now in this numerical expression, let us see 10x cube minus 4x square plus x. These are called as terms. So in this expression total 3 terms are there. Now after terms, let's see what is next, that is numbers. 10 minus 4, these are the numbers attached to variables, so these will be called as coefficient. Now 4 is negative number, so we will be putting minus sign in front of it. So 10 and minus 4 are coefficient, and x cube and x square are the variables, and plus 6 is only number, it's not attached with variable. So when only number is given, it is called as constant. So 6 is constant. Let us see like terms and unlike terms first. Now, like terms. The terms which have the same variables with the same powers are called like terms. Example 7x, minus 8x and 3x. Now here the variables are common, x, x, x. So common variable and the power is same, x, 1, 1 and 1. So these are the common variables with same power. So these 3 terms are like terms. Now let us see another example, 35xy and 3xy. Here variables are same, xy, xy. Common variables and the power is 1. So these 2 are also like terms. Now let's see the next example, that is 4y. These are the numbers, constants, so they are also called as like terms. So like terms need to have the same variables including power, but they can have different coefficients. Now next part is unlike terms. Terms that have different variables or powers are called unlike terms. In first example, 2x square y plus 3xy. Here variables are same but their powers are different. Can you see that? And the second example, 4x plus 6xy. Here variables are also different. So these are unlike terms. So let us see the examples for like terms and unlike terms. First is 5x, 10xy, 12x, then I'm writing 15xy, then 20x square and minus 88x square. Now let's see which pairs are of like terms, 5x and 12x. These are like terms because here the coefficients are different, variables are same. Then 10xy and 15xy. Here also variables are same, so they are like terms. And 20x square and minus 88x square are also like terms. Now what are unlike terms? If we make different groups 5x and 20x square, the variables are same, their power is different, so they are unlike. 10xy and minus 88x square are also unlike terms. Polynomial. An algebraic expression is called a polynomial only when all the variables in every term of the expressions are raised to a non-negative integer power. Means every variable should have positive integer. X square plus 3xy plus y square plus 5 upon 7x square y plus 4xy square minus root 7xy is a polynomial. Why? Because all the variables have positive integer as their powers. If you see x square, x, y, they are also having 1 as their degrees. Then y square, x square y, x raised to power 1 y square and x raised to power 1 y raised to power 1. These all are having positive integers in their powers. So the first criteria of the polynomial is fulfilled here. Then root 7 is there, but this is numerical value. Numerical constant has power 1 by 2, but variables x and y have positive integers as power. So we'll be considering this example as polynomial. Now let's see the second example. Here 7x square plus 4x upon y square minus 8 is not a polynomial because the power of y is negative. Here 4x, the first term is 7x square, x is positive, but middle term x 4x upon y square, if we take y square up, so it will become y raised to power minus 2. So the value of the power of variable is going in negative, so that's why it's not a polynomial. Now in the next example again 7x square minus 4 upon x plus 4 x square minus 5. This is not a polynomial because x is coming in the denominator. When it will go up, the value of x, the power of x will be minus 1. So it is becoming negative. So this is not a polynomial. And in the last example, under root 5x cube y. So these the value of x cube will become, if we open the under root sign, so it will become 1 by 2 into 3 into y raised to power 1. So 1 by 2. So the powers are going in fractions. So this is also not a polynomial. Now let's study few examples on the same concept. These some equations are there. We have to find out whether they are polynomials or not. X square plus 7x plus 12. Now here value of 7x, x variable, the power is 1. So this is a polynomial. Here in the second example, x raised to power 2 by 3 plus x cube. 2 by 3 is a fraction. So this expression is not a polynomial expression. So I am writing it for you. This is a polynomial. Since all the powers are positive, powers of integers, and here this is not a polynomial because the power of first term is in fraction. The variable is having fractional power. So this is not a polynomial. Now the third example, y cube. So 3 is a positive integer. So this example is of a polynomial. This is a polynomial expression. I am writing it in a full sentence so that you will come to know how to write. This is a polynomial expression. Now for the next example, we'll just discuss whether it is polynomial or not. 5 is a constant number. It does not have any variable, but its power is not a negative number. So that's why it is a polynomial. Next example is 4x minus cube. So since the first term itself has a negative value, so it's not a polynomial. Here also negative value, and here 4x square y 1 by 2, power is in fraction, so this is not a polynomial. Based on number of terms, algebraic expressions are classified as monomial, binomial and trinomial. Monomial means they have only one term and non-negative integer exponent for any variable. Whatever variable is there, it should not have negative integer. Then binomials are having two terms with the same condition, that non-negative integer exponent for any variable, and trinomial means three terms are there in that algebraic expression. So let us see few examples. In this first numerical expressions, there are three terms. So 3 means tri. So we will be writing it as trinomial. So I am writing only tri. So this is a trinomial. Now let's see the second example. In this example, only one term is present. So it is a monomial. So I am writing mono. Mono means 1. And in this example, there are 4 terms, that is more than 2 terms. So if expression has 2 terms or more than that, we call it as polynomial. Then again, next example is having 1 term, so we'll be writing here as monomial, and bi means 2. So here 2 terms are there, so this example is of binomial.